Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the question of 1990. So today we have a new question, and hopefully by this week we will upload all the important questions. Very few are remaining. So today we have a new question. I'll write here GATE 1990 uh, question number 15 part first, and it is from mass transfer, and one of the most important topic, that is distillation. Every year one question should be from this uh, distillation. One question in the GATE exam is from this topic, should be, होना ही होना है यहाँ से. So without wasting time, we will go into the question, and question will be visible to your screen. So what question is saying? A continuous rectification column is used to separate a binary mixture of A and B. So we have a binary mixture of A and B, A plus B, okay, a mixture. Distillate is produced at 100 kilomole per hour containing 98 mole percent of A. Okay, so we need to draw a distillation column. Okay, so like this. There are trays. Okay, this is condenser. I hope you all are familiar with the symbols of the unit operations, because GATE recently added those as well, right? This is heater. This will go in. This will go out. This is feed line. Feed. Okay, where we have A plus B. The portion above the feed line is called enriching section or rectifying section. Rectifying section. The section below the feed line is called stripping section. Okay, so this is reflux, that is L. Sorry, that is L, that is D, L, that is V. Okay, that is L dash, liquid will come down, and this is W, bottom product, and after getting vaporized, vapor will go, so this is V dash. Okay, V dash. Okay, now we have value of D, 100 kilomole per hour. In this D, our desired product composition is 0.98. Okay, the mole fraction of A is more volatile, and A is our product. The mole fraction of A in the liquid and in the vapor, liquid and vapor. So liquid composition is shown by X and vapor composition is shown by Y. Okay, and for A we are writing for component A. From two adjacent ideal plate in enriching section are as follows. In the enriching section, from two adjacent plates, so the composition is 0.65 and 0.56, 0.82 and 0.76. So suppose we have a part of this. Okay, if I have two plates, two adjacent plate. Okay, if I will zoom it, here. Okay, if I will zoom this portion, so this portion will be like, we have two plate. Okay, if I will zoom it, Okay, so liquid will go down by itself by gravity, and vapor will go up because gas always go up. And since we are giving the heat in the distillation column, so it automatically get heated up and go up automatically. That is a tendency of gas. And liquid will go down by gravity. Like, so suppose if I write this as plate n and n plus 1, or I can write it 1, I can write it 2, I can write it 0, I can write it 1, anything. Okay, anything you can write. So this composition is 0.65 and this composition is 0.56. This composition is 0.76 and this composition is 0.82. See, 0.65, then the concentration reduces to 0.56 because at the end we will get B because it is heavier and all the A will go up, but a little composition of A will go in the bottom products. That's why the composition of it decreasing, because most of the A is going to the vapor phase. Similarly, here in the vapor phase, the first composition is 0.76, then 0.82, then at the end what we will get? 0.98, right? This composition we will get, because the composition of A in the gas phase will increase automatically because it is our desired for more volatile product. It is more volatile product. At the same temperature, it will vaporize more. Okay, so we will get at the end 0.98. So the composition of A by passing every stage in the vapor phase will increase, and the composition of A in the liquid phase will decrease by passing by going down every stage, right? So remember this concept. Now applying rectification section operating line, this you must need to learn this equation. Rectification section line, what is that? That is y n plus 1 r, that is reflux ratio, r plus 1 xn plus xd upon r plus 1. Okay, so let us complete the question. If the latent heat of vaporization is the same for all mixture, that means latent heat of vaporization will not come into the picture because energy balance will not consider here. Okay, and if the feed is saturated liquid, that is very important. Feed is saturated liquid. Feed is sat sorry saturated liquid. What does it mean? I'll tell you what does it mean. So we know that we are familiar with this diagram, like equilibrium diagram. We will make in McCabe and Thiele method, right? In your undergraduate, you have studied this diagram. So this is diagonal, and this is the equilibrium curve. Now we have 5 conditions. This is XF. XF is the feed concentration, feed composition. Okay, feed composition of volatile substance. Feed composition of volatile substance. Okay. Now this is straight line to XF. Okay, XF straight line. This is totally perpendicular to XF, and this is little bit down. Q greater than 1. Q is equal to 1. Q greater than 0, less than 1. Q is equal to 0, and Q less than 0. The relation between Q and F is equal to 1, where Q is for liquid In the spelling of liquid, Q comes. Okay, so Q is for liquid and F is for vapor. Okay, so always remember when Q is greater than 1, that means subcooled liquid. Liquid will be in majority part and that will be subcooled. Subcooled liquid. Liquid will dominate. Q is equal to 1 saturated liquid. About to vaporize a partially vaporize saturated liquid. About to partially vaporized saturated liquid. Here we have liquid plus vapor as well. Here we have saturated vapors only. Saturated vapors, no liquid. And here we have superheated vapor. छूते ही जल जाओगे. Superheated vapor. Okay, no liquid. Yeah, that means if I put this, F will be greater than 0 here. F will be greater than 1 here. Okay, F is equal to 1 here. F will be uh, greater than 0, less than 1. In between this, then F is equal to 0 here. Then F is equal to less than 0. Okay, like the same, but just follow this equation. Okay, put one value, you can find the other value. Okay, so in the question it is written that the feed is saturated liquid. Saturated liquid, that means Q is equal to 1. Saturated liquid. Saturated liquid. And always remember, gate will ask like this. It will not give directly that Q is equal to 1 or Q is equal to 0 or this or that. It will ask saturated liquid. It will give saturated liquid. It will give subcooled liquid. It will give liquid plus vapor. So if it will give liquid plus vapor, then it will give the value of Q, or one of the parameter, either Q or F. Okay. But for these statements, superheated vapor, saturated vapor, saturated liquid, saturated subcooled liquid, the value is defined. So Q is equal to 1 for saturated liquid. Now find reflux ratio and vapor rate in the stripping section. Okay, reflux ratio, that is L by D, and vapor rate in the stripping section, in the down section, that is vapor rate, where majority is the liquid. In the stripping section, majority is liquid, and the question is saying what will be the vapor rate in stripping section. So vapor rate in stripping section is denoted by V dash. Okay, liquid rate, vapor rate in stripping section. You should all know this nomenclature, stripping section. Okay. L dash denote the liquid rate in stripping section. V denote the only V, vapor rate in enriching section. Enriching section or rectifying section. And L denote the liquid rate in enriching section. Okay, so you all know this nomenclature. Now going to the question. So very first it is asking for reflux ratio. So we have right here applying rectification section operating line, that is yn plus 1 is equal to r upon r plus 1 xn plus xd upon r plus 1, and we have two adjacent plate on which we have composition. Suppose 1, 2. Okay, this is liquid is going up, liquid is so yn plus 1, yn plus y is for vapor, xn for x is for liquid. So this value is 0.65, 0.56, This value is 0.76. This value is 0.82. Then at the distillate we will get 0.98, right? So yn plus 1, that is if I take n equal to 1, n equal to 1, that is first plate. First plate is this one. So this become y2 r plus 1 x1 plus xt upon r plus 1. So y2 is 0.76. y2 is 0.76 r upon r plus 1. x1 is x1, yani x value and at first plate 0.65 plus xt, we have 0.98 in the question. It is given r plus 1. We have to find r, reflux ratio. Okay, so from here r will be 2. You can calculate, right? Now r is written as L by D. Okay, another important thing to calculate the vapor rate in the stripping section, that is we have to find the V dash. The equation which relate vapor flow rate in stripping section and rectifying section. L dash is equal to L plus QF. QF. F is feed. Okay. And V is equal to V dash plus 1 minus QF. F is feed. These two equations are very important because these relate liquid rate at stripping section to liquid rate at rectifying section. Vapor rate at rectifying section to vapor rate at stripping section. Okay, so these are the relations between stripping section and rectifying section. Okay, these two equations will help you to go from rectifying section to stripping section. Okay, so what we have to find? We have to find V dash, and we know that Q is equal to 1. In the question it is given the saturated liquid, so this whole portion will become 0. So V is equal to V dash. That means our job is to find V. So we know that in the stripping section, okay, if I only draw a stripping section, that is upper portion. This is D, this is L, this is V, this is condenser. So from single stream of V, L and D are divided. So I can write V is equal to L plus D. Okay, I divide by D. V is equal to V by D is equal to L by D, V R, D by D 1, V is equal to D R plus 1, V is equal to D is 100, R is 2 plus 1 is equal to 300 kilomole per hour, that is equal to V dash. So this is our final answer, 300. So reflux ratio came 2 and this V vapor rate in stripping section 300 kilomole per hour. Okay, so hope you understand this concept, and this is very important question. Every year there will be a question from distillation in the gate, that is for sure. Distillation is one of the most favorite topic of the gate. So if you have any type of confusion, anything, just comment it below. I will try to reply as soon as possible. If possible, I will share my notes. Okay, so just stay focused and practice, that's all guys. And one important tip I want to give you is that complete your syllabus by October, because November, December and January we have to solve only previous years, and only previous years. We will not look into any other thing. Okay, so bye guys, take care.